Welcome to the What's New presentation of MDA V8.7.2. My name is Matthias Gekeler. At ETAS, I'm the product manager for MDA. In the present video, I'm going to demonstrate the new features and improvements listed here. In the description below this video, you can find the corresponding jump marks. Let's start with an essential improvement in the device mapping dialog. When working with MDA, a frequently conducted operation is the replacement of a measurement file. If the signal names in the old file and in the file for replacement are the same, you probably expect that MDA will update the data directly so that you can continue your work quickly. Preferably, this should be supported even if the devices used for recording had different names. This is the setup in my first example. In the configuration and in the new measurement file, each signal name exists only in one combination of signal name and device. Thus, MDA can conduct the signal mapping automatically, since the signal names alone are already unique. In case of such a clear situation, it can still happen that a signal used in the configuration is not available in the replacement file. As a result, the missing signal will be represented as a signal in no-match state, or briefly as a no-match. In reality, your configurations are grown over the time. And unintentionally, this might have caused that you have within one configuration signals with the same signal name, but with different device information. More precisely, it is the combination of signal name, ECU and device. So when talking about the device, I actually mean the combination of ECU and device. In my second example, you can see that the signal A exists in two variants in the configuration. But in the replacement file, only one signal device combination exists. Then MDA is not able to map the signals automatically. Therefore, the device mapping dialog appears. Let's see which possibilities it offers. In my opinion, just pressing the OK button is the worst choice. Now MDA will replace only signals for which a device mapping was done in the mapping dialog. As a result, most of the signals will end up in no-match state. Therefore, I undo this operation and start again with the selection of the replacement file. The second option is to activate the checkbox at the bottom left. It tells MDA to ignore the device information. Now signals which are already clearly identified by the pure signal name will be matched. This might be better as more signals will be replaced in your configuration. But from the two variants of signal A, only one was resolved successfully. To overcome this situation, MDA V8.7.2 offers a third possibility in the device mapping dialog. I can only recommend to use it if the mapping dialog opens. Basically, the device mapping dialog tells you that MDA is not able to replace the signals in your configuration automatically, as the device names are not clear enough. In the dialog, you see the available devices of the new measurement file in the list on the left side. In the column at the right, all devices are shown which are referenced by the signals in the configuration. In the center, a first mapping was done already by MDA. Here, the ECU device combination in the new file and in the configuration is identical. What is new is that the already mapped entry is still listed at the left. The tooltip tells you that it can be used for another mapping. This makes sense whenever the signal name alone should be already unique. Now you can clean up the different variants of device names in your configuration. These will be merged to just one device. And as a result, the different device names will be resolved. Finally, have a look that all entries on the right have a new counterpart. Of course, only if the new file includes a reasonable device for replacement. After confirming the mappings, there still can remain some signals in no-match state. These are simply missing in the new measurement file. But the more important change is visible for the two entries of signal A. These were merged and now both reference to the identical signal in the measurement file. Consequently, also the number of signals in no-match state was further reduced. And there is another positive effect. In best case, the device mapping dialog will not show up again after replacing a measurement file. As long as already the pure signal names are unique in the configuration and in the new measurement file, MDA will now conduct the mapping automatically, even if the device names have changed. Therefore, I can only recommend to spend once the effort of a controlled manual device mapping and merging. To keep your configuration in such a clear and proper state, here comes another hint. You can trigger the replacement of a signal in an instrument from the context menu. In the Replace dialog, the top row shows you which combination of signal name, ECU and device will be affected by the replacement. On the right, there is a drop-down where you can define that the replacement shall be limited to the current instrument. Usually it makes more sense to extend the replacement to the whole configuration. In case you have signals with the same signal name, but from different devices, you can decide to extend the replacement to all signals with the given name. This means that the ECU device information, but also the file origin, is ignored. However, you can clean up undesired signal variants, but should select this option only if your configuration includes just signals from one file. When the device mapping dialog was introduced, the main intention was a better support of measurement files which include signals from different devices. Even in configurations for analyzing such files, it can happen that over the time superfluous and undesired signal device combinations occur. Then again, the device mapping dialog will open after a file replacement. And in the same manner as already shown before, you can now merge the different device entries. In this section, I'd like to demonstrate an enhancement for the GPS instrument. The GPS map instrument allows to show the driven track in a map. With MDA 8.7.2, the instrument supports that a so-called indication signal can be assigned to the track. It can be, for example, a Boolean signal. Then the color of the track depends on the state of the Boolean signal. In the properties for the instrument, you can define the colors to be used. Also, an analog signal can be used as indication signal. Then a color gradient is applied to the track, and you can define not just the colors, but also the corresponding values. The color of the indication signal overlays the default color of the track completely. And finally, to remove the indication signal again, you just open the configuration manager and delete it from the instrument. Next, I will show how you can easily find out the actual date and time at a specific point in the recording. In MDA 8.7.2, you can find for each measurement file in the MDF format an additional signal. It is named $DateTime. From the meta information about the start of the recording, it is calculated automatically. In the variable explorer, it appears as if it was a recorded signal, although it is actually created by MDA when loading the file. The signal can be added to an oscilloscope. It appears automatically in the script for event signals. As the name $DateTime already suggests, its values show the date and the time information for the selected point in time of the recording. So you can easily find out when a specific event in your measurement file has happened in real. You can also add the signal to a table instrument. There you can see that the precision of the signal is limited to seconds. As mentioned, the calculation is based on the meta information about the start of recording. Thus, the new date and time signal is only available for measurement files which provide such an information. It should also be noted that in recordings with pauses, the values for $DateTime are distorted by the pause event. This is because the length of a pause is defined in Inca by a user option. So every pause in the measurement file has the same length independently from its actual duration. Accordingly, the values shown after a pause event will be typically too low, as the default of the option is 1 second. Another small change I want to demonstrate in the present setup is about the behavior of the time slider bar. As in the past, you can enter the starting value for the visible time range directly in the left field of the time slider bar. As new behavior, the width of the visible time range is kept. This means the time range in the oscilloscope is scrolled and no longer zoomed. However, if a new value is entered in the left field, still a zooming operation can be triggered. Another new feature relates to the axis in an oscilloscope. Sometimes the value range of a signal can be huge. With huge I mean that it varies by more than a factor of 100. In such a case, differences in the signal curve are hardly visible with an ordinary axis scaling. To improve the visibility of small differences, the axis type can now be changed to a logarithmic scale. The handling is the same as when switching to a hexadecimal or decimal axis. Since a logarithmic scale has the same vertical range for each power of 10, small differences can be seen more easily. As before, the precise value for a sample will be shown at the cursor and in the signal list. In the axis properties, you can define how the axis figures shall be displayed. You can choose between an exponential or an ordinary display. The chosen setting will be applied to the values shown directly at the cursor and in the signal list. The next topic is about smaller enhancements for the analysis of CAN bus trace data. The add-on for CAN bus trace files supported already trace files in the BLF and ASCII format. For the interpretation of trace data, a DBC or ARXML description file can be assigned to the trace file. In MDA's File Explorer, for each combination of trace and description file, a separate entry is shown. It has the file extension AFF. As first enhancement in MDA V8.7.2, also CAN bus trace files in the ETAS ASCII file format can be added and analyzed. The procedure is the same as for the other trace file formats. By clicking on the icon for adding bus trace files, a new dialog is opened. In the background, a license check for the add-on is conducted. In the dialog, you can select the trace file, the description file, and define the CAN ID. Moreover, you can define the name for the AFF entry. Actually, the AFF entry refers to a file created in the background. Therefore, you can also define a folder for its location. Afterwards, the entry is shown in the File Explorer. The signals from the newly added entry are listed in the Variable Explorer. The filter categories help to focus on the desired signals. You open the filter categories by a click on the small angle at the left side of the window. In the category source, the desired file can be checked. In MDA V8.7.2, besides the interpreted signals, also the basic CAN bus trace signals are listed. In case the signals do not show any data, you might have given a wrong CAN bus ID. You can check this by a look onto the recorded bus channel ID. In my example, I should have set the value to 1. Therefore, I remove the AFF entry with the wrong ID and repeat the procedure for a new entry. And as a result of the correct CAN bus trace ID, values of the interpreted signals are displayed. The support of FMU models as basis for calculations was extended. Normally, in a real measurement file, no data is available at a timestamp of exactly 0. The first sample for a signal appears usually at a slightly later point in time. Moreover, in case of MDF files, the data for different signals can be recorded in different time raster. The missing start value at exactly 0 can be a problem for some FMU models. MDA will detect such a case after a function instance was created and the input signals were assigned. Accordingly, MDA will apply a corresponding time offset to the input signals in the background. As indication, a warning icon is shown next to the output signals. In its tooltip, the value for the time offset can be seen. To ensure that the original input values and the output values are aligned again in time, the outputs are time-shifted reversely before displaying them in MDA. In the table instrument you can follow this approach. The required time offset is given by the earliest timestamp of any of the input signals. Additionally, a fixed calculation raster is defined in the FMU model itself. In my example FMU, this is a raster of 200 milliseconds. Therefore, the first output value is given at a timestamp which represents the sum of the time offset plus the model raster. Subsequently, the next output values are given every following 200 milliseconds. The warning icon indicating the time offset used in the background is just for information. It will appear only if the FMU model requires a first timestamp at exactly 0 and if the input signal needs to be shifted. As soon as there exists at least one first sample at 0, no time offset is needed. Thus, no warning icon will be displayed. The last feature, which I want to demonstrate actively, is about using lab files in combination with the command line tool MdfConvert. Let's assume your measurement file includes signals with the same name but acquired from different devices. Probably these files include many signals and a lot of data. If you have to handle such files frequently, it might be helpful to extract the relevant signals only. This will create smaller files which can be analyzed more easily. With MDA, the command line tool MdfConvert is provided. It allows to perform such extractions. And for more flexibility, a new option is introduced. Below the list of all available options, some examples are given, including the case how a subset of signals can be extracted by using a lab file. For lab files of format version 1.3, an additional filter can be activated. Setting the option Filter by Device Name will consider the device name information as a filter criterion. For a more detailed explanation, I have prepared some example lab files. When working with MdfConvert, I prefer using an INI file since this facilitates changing the necessary parameters. First, there is the parameter for the measurement file from which the signals shall be extracted. Then follows the name of the lab file for the signal filtering. And finally comes the name of the new measurement file. In the first run, I use a lab file in format 1.2. It contains the names of the signals A, B and C. For some, a raster information is given, but no device information at all. For a comparison, I conduct a second run, but now with a lab file in format 1.3. The same signals A, B and C are listed, and for signal A and B also the device name Stuttgart. After the extraction, I add both newly created files to MDA. In the Variable Explorer, a comparison of the contents can be done easily. For the original measurement file, 6 signals are listed. Thereof, the signal $DateTime can be ignored, as it is created by MDA automatically for any MDF file. The measurement file created with the lab file in format 1.2 includes all signals A, B and C. Signal D is missing as it was not mentioned in the lab file. For signal A, 2 variants from different devices exist, as the lab file did not have device name information. In contrast, the second file contains only 2 signals. Only one signal A with the matching device information. Signal C was extracted as there was no explicit device information. Then filtering is limited to the signal name only. Although signal B was also part of the lab file, it was excluded from the extraction. This is because the information for signal name and device name is handled case-sensitively. Only a slide, a brief hint about an additional component shipped with Inca and MDA. Measurement files in MDF format can include a variety of useful meta information. For example, who has recorded when the file in which vehicle. Displaying such meta information as additional columns in Windows Explorer helps to find the desired measurement file more quickly. With the installation package of Inca version 7.5.2 and MDA version 8.7.2, a new version of the component MDF Shell Extension is provided. Installing the component allows to activate in Windows Explorer some additional columns with MDF-specific meta information. The new version of MDF Shell Extension shows an improved performance and a better software vulnerability. Finally, you see here the overview of all changes done in MDA version 8.7.2. For more details, please have a look into the What's New slide set. You can find it as well as further information materials both directly in MDA 8 as well as on the ETAS homepage. Thank you for your attention and for your interest in MDA 8.